Okay, let's get started. Sound okay in the back? Raise your hand if you can hear me okay. Everybody raises their hand. Okay, great. Welcome to an intro to WebSockets. First of at least a couple of sessions on WebSockets today. So this is a bit of an intro, and I'll mention it again, or a prelude to Jeremy Grelly's talk later today. So if you like what you're seeing here and you want to see even deeper, more in-depth stuff, we'll mention that session again later. My name is Chris Beams. With me is Rossen, Stoyanchev, and Gunnar, Hillert. And we wanted to do this presentation because, as you know, we all work on Spring, right, in one capacity or another. And we've been looking into WebSocket technology and trying to figure out what role can Spring and other frameworks play. What role does WebSockets have in a Java landscape for our community, WebSockets in the enterprise, that kind of thing. And what we wanted to do here is to share that R&D that we've been doing with you, share our findings, so that hopefully we all have a better sense of where WebSockets fit in. So we'll take a broad approach here, try to be pragmatic about things, share what we've learned, focus especially on the Java landscape because that's what most of us probably care about. This presentation is actually live right now on GitHub. You can follow along. It might be a revision or two behind. There might be some tweaks to make after the presentation, but that'll stay up to date and live. So you can even follow along now or certainly afterward. And I'll post that URL again at the end, so don't worry about writing it down now. So, a bit about WebSockets, WebSockets 101. The problem, what problem is WebSockets trying to solve? Well, some web applications need two-way communication, right? Or rapid, low latency updates into the browser. And we've been developing techniques for this for quite a while now, for years, right? Whether it's Ajax or Comet particularly, we'll talk more about in a moment. As the RFC for WebSockets actually somewhat prominently calls out, these can end up being an abuse of HTTP. Not really the intended semantics for HTTP. Things like long polling and so on work, but they're not really ideal. So we end up with problems like browsers creating too many connections, too much overhead when we're trying to, again, have low latency, frequent updates, right? Actually, the overhead of HTTP headers can really add up when you have a whole lot of communication to do. And this ends up being potentially too great a burden on the client, right? Maintaining all those connections, talking to the server in this way, dealing with XML HTTP requests, or even the frameworks that have been built up around that. It's rather complicated to make these things happen. So what kind of applications are we talking about here? Usual suspects are things like trading apps where you really care about speed, chat where you really care about, again, speed, low latency, seeing what people are saying to one another, gaming. You notice we don't really have first-person shooters that are pure web applications. Well, because you die quickly, right? But that actually might be a real possibility in a WebSockets world. Collaboration apps, which we'll show you a little bit of in a moment, or just visualization apps. Anything where you're trying to visualize, especially a lot of data, suffer from this kind of problem. And the goal, then, for WebSockets, this is again from the RFC, for WebSockets 6455, is to provide a mechanism for browser-based applications that need two-way communication, right, initiated from both the browser and from the client, potentially, that don't rely on opening multiple HTTP connections. And the approach to getting there is having, well, two-way messaging over a single connection. So full duplex, bidirectional, that's what we mean here, that messages can be passed from browser to server, from client to server, over just a single efficient connection. It's a layer on top of TCP. It works in concert with HTTP. It's not HTTP. WebSockets is a different protocol, but it's being bootstrapped by HTTP. It's HTTP friendly, you might say. It's also working over port 80 and port 443, friendly with firewalls and so on. It ends up being, potentially at least, an extremely low overhead solution. All right? Let's just look at, quickly, a WebSocket Handshake. All right? This is clearly a browser initiating. That's live. This is clearly a browser initiating a request to some server, right, for a chat application. And as it's doing that, it's saying, I actually want to upgrade my protocol. I don't want to speak HTTP 1.1 anymore. I want to speak WebSocket. And the server, if it understands that kind of request, if it's a WebSocket capable gateway or WebSocket capable server, it responds with an HTTP 101, which I would assume, or I would guess, most of us haven't dealt with much in the past. 101 has always been in the HTTP specification, but it was never actually intended for this purpose. The idea was, this is about upgrading to a newer version of HTTP, saying, I'd like to speak the latest and greatest version of HTTP, like maybe HTTP 2.0. But this is a bit of a clever use of upgrade semantics, a little tweak on upgrade semantics, saying, let's change to a completely different protocol, upgrading to WebSocket. So the server responds, okay, I can upgrade you. And by the time this request response is complete, what's now happening is no longer HTTP. What's established is a single long-running connection, a WebSocket connection. And so what's in a WebSocket frame, right? It's a messaging protocol essentially, and the lowest level form here is individual frames, right? Multiple frames aggregating together into a message that you would actually use potentially at the application layer. I'm not going to go deep into this. Gunnar will talk about a few of these different pieces in the actual low-level protocol. Hopefully you never have to care, right? How many of us are thinking about TCP, SYN, and ACK every day, right? It's quite low level. And we'll talk about that as we go on, that we'll probably see the evolution of higher level usage patterns around WebSocket, that we don't have to think about this. But in the meantime, it's good to understand a little bit about the protocol, especially as it's emerging. So now I want to introduce you to a demo application that we've put together. We call this Bitcoin RT. And actually, one moment. Okay, so this is a glimpse at, I'm going to show this live in just a moment. Bitcoin RT is standing for Bitcoin Real Time. And the idea is, how many are familiar with Bitcoin, by the way, even just nominally? Yeah, so it's an open, monetary format and set of exchanges and so on for exchanging value online, basically. It's sort of a pseudo-anonymous cash online. And Bitcoin is interesting here. It's obviously not the topic of this talk, but Bitcoin is interesting because the transaction history for all Bitcoin transactions, whether it's trades between you and me, currency trades between US dollars and BTC, Bitcoin, it's all public, right? That's actually part of the way that the Bitcoin protocol works, is that everything is public. So you can actually really get easy access to all of this data. And there's a lot of it these days. So it's a high volume kind of visualization situation. And this is actually based on an application called, that already exists, called Bitcoin Monitor, which I'll bring up here. And what you see there is all those little dots. I won't go into too much detail, but you can see transactions, block creations, and currency trades. And this is happening, more or less a real-time view on all of the Bitcoin transactions that are happening globally. And there's quite a few. You can see them popping up there. So how is this actually happening? First of all, we built Bitcoin RT as a demo to perhaps replace this, at least conceptually, because we looked at it and we thought, well, that's interesting, but how does it actually work? If we get into Chrome DevTools here and look at the network traffic that's happening, you can see request after request coming through there. And this is long polling, right? Individual requests being issued to the server, waiting. You can see the length of those yellow dots are longer or shorter depending on how long it finally takes the server to respond with new information. So the client's saying, okay, are there any new Bitcoin transactions for me? Wait, wait, wait. And when the server has some, it hands them back. This creates potentially, or almost certainly, non-ideal latency characteristics, because while you're getting that response, maybe more transactions are happening, and you have to wait until you can issue the next request. That's all happening with full HTTP requests and response, multiple connections, all of the HTTP headers while we go. So that's not great for a user experience point of view, because we're not necessarily getting quite real-time updates. You might argue that it doesn't matter too much here. We're not making trades based on this, but it would be nice. And it's also clearly inefficient use of resources. If you were here, you can actually start to hear my browser spin up, or excuse me, my fan spin up for a few reasons, including the way the UI is implemented. But we could clearly be more efficient, and also from a bandwidth point of view. If you're hosting this app, wouldn't it be nice if you could just pass a few bytes over the wire instead of all this data? So that was a bit of the inspiration for creating this. We liked the functionality of the app. We thought it was a good candidate, potentially, for WebSockets. And again, that's the idea. So monitor Bitcoin transactions. It's inspired by the original Bitcoin monitor. Using WebSockets instead of long polling, we're using a library called d3.js instead of jQuery UI there, which is an aside, but it's a really interesting project for visualizing data. And we're using MongoDB on the back end for persistence. I won't go too much into that, but I mention it because this application is, well, we hope a nice demo. It's not particularly complete or sophisticated, but it's all up online. There are actually multiple implementations. I'm going to show you the node-based demo here, but we have Node plus SockJS for WebSocket fallback options, which we'll talk much more about in a moment. Java-based applications, obviously, again, that's what we mostly care about. Using Tomcat's own native WebSocket API. Using Atmosphere, which is a framework that provides many things, including WebSocket support. And also Vertex. So that's all available for you to see. And again, the URL will be up at the end of the talk. So let's take a look at this. I already have it running here, I believe. Yeah, this is the demo, right? And again, not particularly complete, but it's just proving a few points here. So we're visualizing that same kind of data that we just saw on the live Bitcoin monitor website. But if we look at the characteristics or the way that the application is actually getting that data, it's quite a bit different. Again, Chrome DevTools, looking at the network traffic. Just refresh so that we get a clean view here. So of course we've got some resources to pick up, images and so on. Nothing too interesting there. All of the long polling stuff that we saw a moment ago was XML HTTP requests, right? The browser itself is not refreshing. It's being initiated by JavaScript. But here we don't see any XHR activity. We do see, however, a WebSocket communication. And that's actually familiar based on what we just saw, this upgrade request, the server responding with 101 switching protocols. And we now have that single persistent connection. And you can actually see the individual frames of data coming through. What we're looking at in this viewer is actually really just the payload of the frames of the messages coming through. And that's the JSON data that we're getting through. I realize that's a little hard to see, but it's the trade amount, where the trade exchange was, the amount of the trade, and so on and so forth, specific to that domain. But very, very, very concise, right? We could be passing around just a couple of bytes over the wire, even, minimally, right? And here we're passing around just as much as it takes to express the details of that trade. So much more resource efficient, so on and so forth. Yeah, the question is, could it just as well have been binary data? And that is certainly accommodated in the protocol, right? Textual data or binary data, most definitely. So with that, you might be thinking, okay, well, WebSockets are really cool, right? It makes sense. It's a logical evolution given the needs that we have in web applications today. So it's a silver bullet, right? Let's all just run out and convert everything to WebSockets. Of course not. Why is it that we see applications like Bitcoin Monitor, the original application that I showed you a moment ago, why is that still using long polling? Well, it could be that it's just an old application and it was built before WebSocket technology. That's possible. Or it could be that there are some problems with using pure WebSockets in the wild. Rossen will get into more of that in a moment. But I want to give another example. Just in case it was the fact that Bitcoin Monitor is old, let's actually look at a very modern application. I mentioned collaboration applications are a kind of usual suspect for taking advantage of WebSocket functionality. And let's see if we can take a look at, this is Asana, asana.com. We actually used this application. This is like a task management app on steroids, right? Collaborative, writing tasks to one another, hopefully seeing updates in real time, that kind of thing. So, I can type something here like give presentation at Spring 1, and hopefully I'm going to see, my colleagues are going to see that update come along in real time, right? Like maybe you could type something. And, well, that makes a lot of sense for WebSockets, right? I mean, we're typing at the same time. We want to see updates. How does this work? This is a brand new application, right? Built just in the last year or so, built by some of the original folks at Facebook. So they probably really understand all this technology. In fact, though, if we inspect again, what's happening here? Well, we have XML HTTP requests, multiple requests going by. Any WebSocket traffic? No, actually. So why would this application still use long polling? Right, it's brand new, it's modern, and that's, well, a bit of a segue for Rossen to take over.
Okay, and after this high-tech switchover, as Chris mentioned, we have mainstream applications like Asana, built by people who came from Facebook, right? So they should know how to build an application like that. And they've chosen to do long polling, and there are lots of other examples of that. Again, the question is if WebSocket is so much better for these kinds of scenarios. There are clear advantages. Why is it that it's still doing things like long polling? And the first topic that I'm going to, the first answer to this question is first, if you take a look at the browser support, what you see here, and it might be a little small to see in the back, but if you focus on the colors, that will probably help. Essentially, at the top, the columns are the different browsers, starting with Internet Explorer and Firefox, Chrome, the main ones. And then below that you have the individual versions of these browsers, and then in pink color are versions that don't support WebSockets. In this darker green color you have some kind of support, or maybe support which is not enabled by default for various reasons, which Gunnar will talk about, things like security considerations at the time because the spec was evolving. And then in the lightest green you have, typically near the bottom is where you have support. And what's interesting to see here is that if you look at the latest versions, a lot of these browsers do support WebSockets, and they support now the RFC final version of the protocol. But we'll take a look in a moment at the actual deployment numbers, and you'll see that the picture looks a lot less hopeful as of today. Probably the one interesting thing to point out there is the Android browser, which is the green on the right-hand side, which does not support WebSockets. And then other than that, I mean, you can see Internet Explorer will support it in version 10, which is a future version, essentially. These are stats from a website called StatCounter, and those are the numbers for the individual browsers worldwide. At the top is Internet Explorer, and that's upwards of 40%. So you've got almost half the average browser users that essentially don't have access to WebSockets today. And then below that is Firefox and Chrome and so on. Now, it's also something that varies regionally. So if you take a look, for example, I picked China because it's actually one of the examples where it's a bit more stretched out, a bit more extreme, and here the usage of Internet Explorer is close to 90%. So depending on which regional market, and there are other variations, for example, in Europe there are places where Firefox is more popular than Internet Explorer, so the picture changes, but the point is that by and large, if you want to build a public website and if you want that to be accessible in a lot of different scenarios, a lot of different contexts and regions, then chances are you're going to have to do something else which is a common denominator for all of your users. And this is the other aspect that I mentioned. These are the browser versions. So for example, we have Internet Explorer at the top. You know, that's not surprising. But then, and I'm sure it's impossible to see in the back, but probably, well, the second one is Chrome. And then a little bit further down, just maybe that's the fourth one, I think, yeah, in kind of a brownish color. That's Firefox 3.6. So Firefox 4 is the first version that actually supports WebSockets, and I think it's not even enabled by default. So what you see is actually a fairly large user population which is on Firefox version, which is earlier than where WebSockets is supported. You know, and we as developers tend to have a different perspective. You know, we have computers where we upgrade the operating system and we get newer versions of the browsers, but if you look at the user population at large, you'll see that the picture is actually quite different. A second challenge to talk about is HTTP proxying. So when on the internet we have intermediaries, we have different kinds of proxies, and these proxies can do things like content caching. They provide internet connectivity, for example, from inside a firewall. They can do filtering, and HTTP proxies can monitor connections. They can even close connections if they decide that you know, the connection is taking too long. Maybe the server is unresponsive, so they can do things like that. They can also buffer unencrypted traffic in order to try to optimize. Essentially, they were designed for HTTP-based document transfer. They were not designed for a situation where you have a connection which is open for a long period of time. So there are specific challenges that stem from that. And this is a quote from Peter Lubers from Kazing, and Kazing is one of the companies behind, they're the people who actually were involved in the creation of the WebSocket spec. So their opinion here is definitely counts. So basically the quote is that most transparent proxy servers will not yet be familiar with the WebSocket protocol. And what this means is that, and we'll talk about the connection issues as well, but even if you establish a connection successfully, actually the traffic that continues from there doesn't look like HTTP traffic. It's just fragments that go back and forth. You know, the initial handshaking is HTTP based, but thereafter what you have is an open socket and you're simply exchanging frames bidirectionally. And that simply doesn't look like HTTP traffic, so a lot of proxies will actually possibly not choose to continue with that connection. So what are actually some of the issues? I'm not going to go into a lot of detail here. This right here is a link to the InfoQ article, so you can click on that link once you go through the slides, and that will get you to the full level of detail. But essentially you have things like explicit proxies. And explicit proxies, for example, when you configure your computer with a proxy in order to access the internet when you're inside a firewall, that's called an explicit proxy. And in that case, you're doing an HTTP connect to the proxy, and that sets up a low-level TCP tunneling so that you can communicate with servers that are approved by that proxy. And when you're doing that, it's actually because of the setup of that tunnel, that actually makes it easier for WebSockets to work because the intermediaries are not going to get involved in trying to see what the traffic is. The other thing that you have is, especially if you're not using an explicit proxies, then you have intermediaries like transparent proxies. And because we're sending an upgrade header in the initial handshake, that upgrade header actually only counts for one hop. And it needs to be propagated with each intermediary. So if the proxies are actually not configured to do that, which by default they wouldn't be if they are configured as they should be, that means that the upgrade simply will fail. Now, apparently not all proxies are configured in this way, but there's a good chance that that will not go through. Also, proxies are often configured to strip the connection header, which is again part of the initial handshake, and that can be another issue. Even if you do manage to establish that connection, once again, the traffic that continues from there, first of all, it's going to continue for a long time, and most proxies are not going to tolerate that. But also, you have traffic which doesn't look like HTTP traffic, so proxies need to be configured in order to support that. So it's not all gloom and doom. Actually, there are ways to improve the chances. For example, if using secure WebSocket connection, even though there's a cost associated with doing that, a resource cost, actually that provides a much better chance of success because the encrypted traffic is not going to be interpreted by the intermediary proxies. And they're more likely to basically not buffer it and not try to interpret what's going back and forth. Browsers with using explicit proxies are also more likely to work, especially in combination with secure WebSocket traffic. And then the last point to make is that proxies aren't inherently incapable of handling WebSocket traffic. They're just not, by default, they're not configured. And as you can imagine, the challenge is that we have so much infrastructure built on the internet that it's going to take some time before all of that is in place so that WebSocket traffic can flow predictably. And then we have another sort of question to consider, keeping connections alive. Once again, if we're moving from a paradigm of document transfer to a situation where we're going to open a connection and we're going to send things back and forth, and that's very efficient, very effective. But we're just not, that's not what we've been doing. We've been, sending messages back and forth, and HTTP has built into it reliability so that, if the connection doesn't succeed right away, it's going to try again. And that's something we don't even need to know. But when you start working with WebSockets, you now have a long-running connection. So you have to think about everything that comes from that. Internet is inherently unreliable. So both the server and the client can go away at some point. You have this challenge that you have to, first of all, try to know exactly when the browser or the other side has gone away, basically. You can have wireless connections that are dropping in and out, and so on. So, you have to think how the application should behave at that point. Chris was showing Asana, and for example, when you start to lose internet connectivity, Asana will dim the application user interface, and then at the bottom it will show a message that allows you to click on it, and it will explain you further that you're in offline mode and you can browse, but you can't really, nothing will get saved until it will sync up once you're connected again. So this is kind of a new, it's a little startling to see even as a user at first, because that's not what we're used to seeing in browsers, but that's sort of the mental shift that we have to switch to. And then the other thing to think about is that with WebSockets, when you send a message, even if you send it successfully, you actually don't know if it's been received on the other side. Again, it's that kind of communication that we have, it's a very low-level communication if you think about it. We're just exchanging messages. There is really no protocol on top. So you would need something like, for those familiar, I'm sure most are familiar with JMS. That's something that JMS as a protocol provides. So you would need something like it on top in order to get some sort of confirmation, and now you know for sure the other side received the message. Also with unreliable connections, obviously as you know the internet or the connection goes away, you have to think about buffering of messages as well, because if the client continues to produce, if we're using Asana, we continue to produce data, then at some point we need to sync up. So you need to think about buffering on the client side, buffering on the server side. So all of this is kind of a new set of challenges that come along with having this long-running connection between client and server. So the other things to keep in mind is, well, there are some things available, and Gunnar will mention some of them when we look into the protocol in a bit more detail. But we do have sort of the notion of keep alive messages in the WebSocket protocol. So you can send a message that says ping, and then the server responds with a response called pong. These are specific types of frames that you can send. And this is something which can be used by browsers, for example, to make sure that the server doesn't time out, you know, that the connection remains alive. Then we have a higher level concept of heartbeat, which is a bit more sophisticated protocol between client and server to decide when the other side has gone away. For example, they might both come up initially and negotiate how often should we ping each other. And if you don't ping me, if you don't hear from me in a certain amount of time, then you can assume that I've gone away. So that's sort of a heartbeat protocol, which isn't quite there yet. It's not built into the protocol, but it's something that can be done with ping and pong messages. Message delivery guarantee buffering we mentioned. So now that we've looked, we have some basic understanding of WebSockets, how it's similar or different to HTTP, and what are some of the basic challenges. Let's take a step back, and I'm going to switch over to Gunnar, who will talk about how we got here, a little bit of history, the WebSocket spec itself, and what are some of the other relevant specs that you should know about.
By the way, if you're following along in the slides on your laptop, refresh the page, because we've just pushed a new version.
Okay, so the question is how we got here in the first place, and it's kind of interesting to look in that regard at where things basically started. And let's start with some history. You could actually do sockets on the web all the way back in 1996 when Java applets came along and were available as part of Netscape 2. Things just started, however, lingered around like so many things, and a big change on the web world was when we got the XML HTTP request object, which we now today value as AJAX. So that was a big changer for our web world. And then in 2003, also Macromedia, Adobe Flash, with their RTMP protocol, provided you facilities to do socket communication as well, using the Flash player. So we have the world of AJAX and that kind of interaction, and then Comet came along, so which was similar coined to AJAX. So we saw the rise of application at the time in the mid-2000s that facilitated server push event-driven data streaming, and Alex Russell wrote a blog post, let's just call it Comet, kind of like what was done with the terminology around Ajax. So just to reiterate, Comet is event-driven server push data streaming. So it's push technology. It's not WebSocket. WebSocket takes it a step further, so I would not categorize WebSockets as a Comet technology. So we had a few technologies around Comet, or kind of like almost hacks basically, to make that happen with the existing browser technologies. So we have XHR long polling, multi-part replace, streaming. There were some hacks on Internet Explorer that were possible, like HTML file the ActiveX object. And the culmination of this one is actually quite interesting, is server send events. So this is actually part of the overarching HTML5 standards umbrella, and much simpler than WebSockets. Does push technology, works on top of HTTP, so that might be a technology to look as well as an alternative to using WebSockets everywhere supported except one browser, and I guess you guess which browser that is. I may not go into those details, but hopefully with IE 11, maybe. So it's not on the horizon for IE 10, at least I couldn't find information on that. So with that, we have the push technology. But what about communicating back, establishing that bidirectionality? So the path to WebSockets, Ian Hickson did a TCP connection API in 2007, which is the precursor of WebSocket, which was a public draft in 2008, and then took a little bit longer before it went over to the IETF, the Internet Engineering Task Force, for standardization. So here we have two phases over at during the standardization process. We have, it started in 2009, went all the way up to 2010. The important portion here is to remember that basically when you see HIXY, OO, those are 75, etc., those are the different draft versions. So whenever you do research on Google regarding WebSockets, you will see in different frameworks potentially still using older draft versions of the WebSocket protocol. So they should not be used, but you still may encounter those in your research work. Chrome 4 was the first one that was providing WebSocket implementations. In 2010, we had HIXY 76, and it was decided to disable that actually due to security concerns in Firefox and Opera. At that point also the standardization was handed over to a new working group, and also the security model was changed, etc. So there were some changes in the protocol, including supporting binary data communication for WebSockets. And then in 2011, December, we have the RFC 6455. So that's the final version for WebSockets. And so if you look at it, it's not that long ago. So we basically just a year ago, we have now a final draft of the protocol. So which doesn't necessarily mean we're talking about the API, which was later. So let's talk a little bit about the WebSocket protocol itself. It's, as Chris said, TCP-based protocol, HTTP only for the upgrade used. We have that status code 101, bidirectional, and text and binary data support. We have unencrypted and encrypted data schemes. Should prefer the encrypted one. Interesting one is the handshake. So we send basically specific HTTP headers to the server side, the key, which will basically it will allow the client to identify the origin of the server communication. So we basically send that key up there. We use that. There's a magic key they define that you basically append to your key, hash it, encode it back, and send it back using the WebSocket accept header. And at that point, you basically establish a WebSocket communication that that's outside of HTTP. So the protocol details. Let me refer back to Chris's the diagram he had put earlier. So this is kind of like the how the protocol is defined in the various section. And let me talk about a few elements here. I might have to go back to the slide a few times. So the first is the final fragment in the message. So that's the first bit we have here. It basically identifies when you have WebSocket communication, you can send multiple frames basically. So a message can span multiple frames, and that bit identifies that is the final element. We have a few bits that are reserved for extensions. We have the opcode, which basically identifies which type of a payload we're dealing with. Are we textual, binary, or is it part of a control frame? Also, we have a continuation frame, which basically identifies this frame this message basically constitutes multiple frames basically. We have a masking character, so that's kind of interesting. For clients it is mandatory to mask the data to minimize data sniffing, and this was kind of interesting to prevent kind of like there were some security issues with the original drafts, and to basically prevent proxy cache poisoning. So apparently, this is my vague understanding, is that apparently there are lots of proxies out there that are faulty, not up to code basically, and WebSockets communication can basically trip those theoretically up to interpret WebSocket communication as HTTP and therefore provide cause security issues. So we have the masking. Then we define the payload length. So that's a 3-step process. We have different depending on multiple sections in the that we can define the lengths for. So basically 7, 16, or 64-bit in length, and we use the spaces differently depending of how. If it's just a short message, let's say your frame is only less than let's say 100 bytes, for example, then you can just use the first section of those 3 different spaces available to defining the length. The length also defines extension data plus application data, so the payload itself and the message. When you look under that bottom section, which is titled payload data, that basically can be extension data or application data. So you can, on top of the WebSocket protocol, it also defines extensions. You can also extensions defined that can have their own definitions, basically. So that's kind of like the raw definition, the 30,000-foot overview of that. Let's take a quick look at control frames. Have this amazing graphics from Ping and Pong, because we have control frames communicate the state of your communication. So we have the close, the ping, and the pong. And more possible in the future. The close terminates the WebSocket connection. It can contain a body, so you technically you can have contents, error messages, etc. also communicated back for debugging purposes. Never supposed to show up though in end-user UIs. That's explicit in the spec. It also defines status codes. For example, 1,000 for normal closure, 1,001 for that the endpoint is going away. So there's a long list of status codes as well. And we have the ping and pong frame, which kind of like, as Rossen mentioned, it technically, based on the protocol, and that's my interpretation, it can serve as it specifies that it's be usable as a keep alive. A ping is followed by a pong. You can use it to check if the remote endpoint is still responsive. It can be sent at any time, even interleaved into the data frames. And you can only send just pongs. So for a unidirectional heartbeat. But I will refer that point when I talk about the actual API for WebSockets. I'll go back to that. WebSockets also defines extensions, or has the possibility of extension, and this is still not finalized, or at least there are two drafts I could find out there. One is for compression, and the other one is for multiplexing extension. So for those, you send an extension headers, sec WebSocket extensions, and it's used in the opening handshake via HTTP. So I just want to briefly mention the multiplexing extension for WebSockets. So that's basically in cases that you may actually span multiple connections over to your server using WebSockets. So the idea is that you could reuse, basically create a logical WebSockets connection going over one physical WebSocket. So that's part of that specification, still also in draft status. So I just want to mention that as well. And we also can provide sub-protocols on for WebSockets. So there also has its own protocol header, and for sub-protocols and extensions, as well as for all the codes, there's an IANA registry under www.iana.org. So you can look all those up, and right now there are just 2-3 sub-protocols defined, including one from, you guessed it, Microsoft, which guess what they implementing over WebSockets? SOAP. Yes. So whatever. But it's there. So and this is an interesting area that we will probably see more when we talk about WebSockets itself. So we don't really expect, necessarily end users to use it, but there will be actually, it defines already that level of additional services and or protocol or services basically defined on top of the WebSockets protocol. However, when we talk about HTML5 and WebSockets, what we usually mean is not just the protocol, which I literally just scratched the surface on, but also the W3 API itself. And it's a candidate recommendation, September 2012, so it's getting pretty close. And also supports binary supported via blob or an array buffer in JavaScript, so you can actually do binary communication from your browsers. You can take a look at what your extensions are, but this is kind of interesting. So within the API, you cannot have an impact on the extensions. That's kind of like left to the browser itself to use those. Also, even though the protocol defines ping and pongs and potentially useful use cases for that, there's no support for ping and pongs in the API specified at all right now. So that's literally just left over for the browsers itself. We have different states you can inspect when you do a connection using JavaScript. Are you connecting, opening, closing, or everything is closed? You have event handlers you can hook into to basically get messages on open, on message, on error, on close. And just a quick example of how you would actually establish a WebSocket communication. So you have the WebSocket object, and you can actually, in the constructor, you can also, if there's a sub-protocol, you can also specify the sub-protocol you want to use. And then basically the on message, you will receive the data and you can use the data, or you can use any of the other listeners for those. Finally, I also want to just mention, since I'm giving you an overview of the specs you need to be aware of, there's also JSR 356, the Java API for WebSockets, but Rossen will go more into those details basically in just a little bit. So we're talking now about non-Java solutions.
Okay. Chris showed briefly earlier the node-based sample, and that's what I'm going to talk about. Thanks. With Node.js, we have actually quite a few options. You will generally see a split between JavaScript and Java, and JavaScript is a little bit ahead in terms of providing support for WebSockets, whereas in Java land, which we'll talk about in a moment, we're currently working out the Java API for WebSockets, and there's tons of good discussions going on there, so I think that's a necessary process. And you will also, referring back to what Gunnar was talking about, there's a lot going on. I mean, we have the RFC spec, which is final, and it's been final for a little bit under a year, but it's been evolving since going back to 2008. We have things like extensions, like the MUX extension for reusing WebSocket connections efficiently. Unlike HTTP, which browsers don't recommend opening more than a certain number of connections, with WebSockets you can actually open any number of connections, but it's not recommended. It's better to try to reuse connections. So for this reason we have the multiplexing spec, and that's going to plug into the WebSocket spec on the level of extensions. And extensions are kind of a low-level concept, so when you provide an API, that's part of what you have to think about, how to actually make that possible. So with Node, some of the options here, well, the main options are you have a WebSocket package that you can install, and that gives you essentially raw WebSocket access, both client and server side. How many have installed NPM packages or have some familiarity with Node? Okay, a few hands. So basically, once you have a Node application, and we have instructions in the samples, so if you go into the source code for the samples, each subdirectory actually has a README, and you can follow the instructions and see how relatively straightforward it is to put this together. In addition to the raw WebSocket package, we also have a couple of others that are really very central to the talk that we're going to be, the things that we're going to be talking about from here on. Essentially, we have socket.io and SockJS. And these are more than just WebSocket APIs. They're more than just WebSocket implementations. Actually, they provide a whole bunch of fallback options because, as we discussed earlier, you can't really practically use, it's a bit of a unicorn, right, trying to use WebSockets today in a public application because of all the challenges with browser compatibility and so on. So it's actually very important to have some kind of fallback options. And what the options are, I'll mention here. First of all, we have XHR streaming, XML HTTP request streaming. And essentially that amounts to starting an HTTP request and then keeping that connection open and continuously sending or streaming data back to the client. And that may or may not be supported in browsers, so even some of these fallback options may or may not work. So that's really what something like Socket.io provides, or SockJS, where they'll actually figure out what works and continue to fall back on in order of preference. We have also long polling, which is like polling, but the server holds until there is data to be returned. So it's more efficient than polling in many cases. We have also a hidden iframe, which is an iframe that gets opened and remains there, and then the server is sending essentially script tags that get executed in the parent frame, and you know, that's the mechanism basically for sending things down. There's also non-HTTP based solutions. There's things like Flash Socket, and of course with Flash it's been possible for some time to do something similar to WebSockets, but there are some drawbacks there as well. They don't always work. They need a port, so if you have a firewall, that could cause problems. And then, of course, you can always fall back on regular polling. The Socket.io library is actually a little bit more than just transport mechanisms. It provides sort of higher-level constructs and lots of different options. It's sort of like the go-to option in the JavaScript world. That's really the popular choice. Obviously, there is support for WebSockets. They do support Flash Socket, so they provide that. AJAX long polling, streaming, as well as hidden iframe and just regular polling. Now, if you look at SockJS, on the other hand, SockJS is actually much more focused on the transport layer. And you see a whole bunch of options here, maybe not so visible in the back, but you have the different browsers on the left, and then you have kind of the general categories, WebSocket, streaming, polling, and you can see it all spelled out. What's interesting is for Internet Explorer, there's really no WebSockets and no streaming in version 6 and 7. In other words, you can't really open a connection and send discrete data. It'll only give you the whole data once you're done. So the option for streaming is not possible there. And that's why really polling is the common denominator in that environment. So you can kind of see the sort of constraints that you have to work with if you actually want to make the application work. In terms of Socket.io versus SockJS, well, Socket.io is really the sort of the I would say the mainstream option, the one that's more known within the JavaScript world. But SockJS is actually focused on transports and is much better defined protocol. If you think about fallback options, that requires a kind of protocol between the client and the server. So the client has to say, okay, I'd like to, the server is going to respond and they're going to try first of all to interact using WebSockets. Then if that doesn't work, they might try streaming. And then if that doesn't work, they're going to move on to something else. So that's why there's a kind of protocol, and if you have a solution on the server side, it has to match the solution on the client side. That's why they need to be coordinated. And the protocol for SockJS is much better defined. They have a very extensive test suite that demonstrates what should happen in various scenarios. And as a result of that, what you'll find with SockJS that there's actually a number of different implementations. The list is growing in different languages, so it really spans and goes outside of the JavaScript community. So we actually think that SockJS is got a pretty good chance here for spreading out. I should also mention that Socket.io, there's an effort to split out. There's now a project called Engine.io, which is aimed to be just the transport layer instead of providing a whole bunch of other options on top for messaging. And that's going to be a little more comparable and in line with what SockJS provides. And we have a link to a discussion thread, which is on the SockJS forums, so you'll get opinions from the SockJS developers. But it is a pretty meaningful thread, so if you want to get a better idea, that's a pretty good place to start. And now we're going to talk about where we are in Java land. First of all, we'll talk about Tomcat. Tomcat now has support as of version 7.0.27. So earlier this year, there is support for WebSockets. There's a WebSocket Servlet. So this is server-side support, basically. And there is a ticket for actually backporting it to version 6 on top of the Tomcat Comet support. So that's something that you can expect. And I'm going to show you quickly a little bit of the sample code. I'm not going to actually run it because we don't have a lot of time, but you can get the source code. So you see here we have a Tomcat servlet, Bitcoin servlet, which extends from the Tomcat WebSocket servlet. And essentially we override the method called create WebSocket inbound. So it has this inbound and outbound types. And when you create that stream inbound, essentially you're providing an implementation of this interface, and then you can respond to text messages to binary messages. You can hook in when you're opening and closing the connection, and that's really pretty much the extent of the API. It's very simple, it's very straightforward, and I think it was probably smart on the part of Tomcat to do that. If you look at some of the other APIs, the initial attempts were really the kitchen sink of every available option in the protocol, exposing every concept. And we'll talk about that in a moment as well in the context of the JSR. Just to mention a couple of other things here. So this is the Tomcat servlet, which is going to serve the browser to stream data to the browser. But we also need to pull data from the MTGOX source. We need to get the Bitcoin data in order to stream it down. And for that we have actually a Java-based client. For example, we have a Jetty client here. And that's going to initiate a connection to the MTGOX service. And you can see here that we're going to receive messages and then broadcast these messages, so the Tomcat servlet will stream it down. And I'm only going to mention that we also have a async HTTP client implementation of that. These are just multiple implementations of the same WebSocket client, and we have a stub version so that this can work in offline mode as well. And then we have a Servlet 3 web application initializer where we programmatically register this servlet. And we also have a listener that's going to start and stop the client, which is getting the data from the MTGOX service. So all in all, it's pretty straightforward. Nothing really too much to see here. But you can certainly check out the code and spend more time running it and playing with it. So the Tomcat API is fairly minimal, server-side only. Jetty has really been an early adopter of WebSockets, starting with Jetty 7. The early versions, like I mentioned before, exposed pretty much everything, fragments, and just really trying to figure out to make sense of it. Now, as of maybe a few weeks ago, just a couple of weeks ago, we have Jetty version 9, and the WebSocket implementation was completely revised, so it's not backwards compatible. And that's probably a good thing. Essentially, they built on Java 7 using some of the non-blocking features in Java 7. And they are now no longer exposing frames in the API. So the API has been significantly simplified and revised. And I think a lot of that is actually driven by, first of all, by discussions in the Java WebSocket API, JSR 356, because if you look at a lot of the earlier discussions, they was talking about, should we expose fragments? Is that a kind of a lower level extension? Should it be part of the main API? And I think these discussions sort of influence well, that and the evolving notion of what a WebSocket API should really look like and how is this going to be used from applications. So it's very much an evolving story. Also, Jetty is involved in a lot of the RFC specs, including the multiplexing extension. Again, that's work in progress, and it's also influencing in a major way sort of the thinking of how do we design this and make sure that when multiplexing becomes available, that can be accommodated as well. They have annotations. This is, again, something which is probably in part influenced by the JSR 356 discussions. Glassfish, not much to say there other than it's been there for some time. Once again, early adoption, lots of options. My personal expectation is that you will see a revision of that as well once the WebSocket API becomes more clear. And then outside of that, we have other implementations like Atmosphere, which is a lot more than just WebSockets, and Gunnar is going to talk about it shortly. We have JWebSocket, which is pretty complete actually as an implementation, LGPL license. We have Netty and Vertex building on SockJS. So Vertex is an interesting option actually because it builds on top of SockJS and provides more than just WebSockets. And it has a pretty clean API. And then we have things like Grizzly. Of course, Grizzly, Netty, these are not servlet container environments, but they very much provide these options. And then let's not forget that there is a client side, so there's a symmetry here. We have the async HTTP client from Sonatype, or actually the same creator as Atmosphere. Jetty provides a client, also Netty, Vertex, Grizzly. You can pretty much expect that eventually everybody providing a WebSocket API is going to have symmetrical support on the, for client and server side. And this brings us to the Java API for WebSockets. The original discussion started actually as part of the Servlet spec, Servlet 3.1. And then pretty quickly it was realized that that doesn't belong in the Servlet spec because you don't actually, you could be running WebSockets as a client, so you don't really need to be in a Servlet container. It's just not really the place to define all of this. So it was split out into a separate spec, JSR 356, and the only thing that will probably be in the Servlet spec 3.1 is just the option to actually use your Servlet container to upgrade. Because you're probably going to want to use security options, you're going to want to use the session, HTTP session of the user, probably share some data with a WebSocket session, things like that. So there will be some touch points between the Servlet world and whatever the final version of the WebSocket implementation is, but that's still very much a question. There's a good chance from the discussion so far that JSR 356 will not have a hard dependency on the Servlet API. That's something that is logical and something that you can expect. What's being discussed? Definitely there will be a client and a server-side API. Use of annotations looks pretty certain at this point, so there will be some sort of a POJO-based programming model for all that. The details, well, there's actually an early draft available already, but I think there's still a lot of time for things to change based on feedback. There will be support for extensions. That's something that's been discussed. Security considerations, the threading model. So there's tons really to be discussed, and there's a lot that's going on in those discussions. And that's a good thing. So I think the result of that is that we're going to see a pretty good, probably WebSocket API coming from this. If you want to see some resources, I have some links to all the drafts so far. You can also see the latest draft as of today, and that's the early draft. It's been proposed as the early draft review, so it's it reflects a fair amount of discussion already. And then you can also refer to the actual mailing list archives of the expert group for more details.
Okay, we mentioned Vertex. I just wanted to make a few words about talking about Atmosphere. So while you have various options, let's say running native or pure WebSocket implementations on top of your Servlet container, you still are interested in fallback options, and you're also interested in potentially being having portable web applications that run across containers. And you may not want to go the route of Node.js or Vertex, even though that's certainly a good alternative in that regard. So Atmosphere is actually probably the best option you have right now in the Java world to create portable WebSocket and fallback supporting applications. And we have a sample in there. So just wanted to briefly go into the code. What we have. So starting with the, it's the same application, so I'm not going to show it. It's basically it creates the same UI, and we have the Atmosphere object, and we basically create a request. We provide the URL we want to connect to, the content type, what kind of transport fallback options we are willing to do. So we have support for polling, long polling, streaming, server sent events, as well, and then of course a WebSocket if available, and kind of like a messaging API, so on message, etc. So take a look at that, play with that. You subscribe to the socket, and then your communication starts. The way it works is you have a filter in your a Servlet filter in your web.xml or in your initializer, and it basically wraps. It provides, in a sense, it provides all kinds of other web frameworks, but it also provides somewhat, not perfect, but it provides doable integration into Spring MVC in that regard. So basically, you can wrap the Servlet, your Spring MVC application context, and basically expose the Atmosphere APIs basically within your Spring controllers. So I have, to make things a little bit easier, I have an argument resolver. So that basically allows me to in my controller to basically inject basically your Atmosphere resource. And the Atmosphere resource, that's basically, if you connect a connection to your container, to your server, you basically create an Atmosphere resource, which itself can have events. So we have a little Atmosphere utils in here where we actually do the suspend, create an Atmosphere resource event listener, and then can act whenever messages come in. We have we have basically the unsuspend here. We have an on disconnect, on broadcast, etc. And in our home controller as well, we have, and then from that on, we basically can broadcast messages to basically other connected clients, etc., or intercept that on the server side itself. So so that's certainly an option for you today using Spring MVC, providing fallback options as well as also portability across containers to some degree. So I just want to mention that since we are running a little bit short on time. So also one last option. We have one of the samples is using Vertex as a standalone Vertex option. Another option is to also provide embed Vertex into your application itself. So there's also an embedded sample as well to embed Vertex into your Java options, not just running it as an external process as well. So just want to mention it. Check out the samples. And with that, I hand it over back to Chris.
Can you switch? Okay, so what we built in those demos is definitely a trivial application in that, well, some of them at least assume a pure WebSockets kind of communication. For reasons that we described, that's probably not likely. What do we need to think about when building a non-trivial application, a real application out in the wild? I think we can draw a few conclusions at this point, at this relatively early point, that WebSocket technology is indeed promising, right? It's not just hype. It's also not a silver bullet. Right? This is something that's a complementary technology that you can think about. The need for it has been battle-tested and proven over the last years. We've seen all of the comment techniques and so on, and that's really what's led to WebSocket. It's not something built in an ivory tower. It's really based on sound ideas and engineering. So it's, again, a complement to things like REST. We shouldn't be having REST versus WebSockets as if one or the other is the answer or something like that. We'll see both of these peacefully coexisting. WebSockets is indeed a potential replacement for these comment techniques that we've talked about, like long polling and XHR streaming and so on, but those techniques aren't going away anytime soon for the reasons that we discussed, right? Intermediary problems, proxy problems, browser compliance issues, right? It'll be a long time until the very last browser out there is WebSocket compliant. So if you need to approach 100% capabilities, you'll be using fallback options for a long time. All this means together is that while WebSockets is a great technology, it's not trivial to integrate into a real application yet. It is, we think, the time, particularly for our community, right, the enterprise Java application development community, to begin thinking about it, right? Looking at your own applications present and what you imagine in the future. How can they take advantage of WebSockets, or what are the use cases that you see in enterprise applications and so on for WebSockets? So beginning to think about it, getting yourself familiar, attending sessions like this, right? And keeping in mind again that, like Rossen said, it's a little bit like a unicorn to see a pure WebSocket application out there in the wild, unless it's like a demo app or something like that that's showing off WebSockets. We'll probably see, to make a few predictions here, we'll probably see a consolidation of these fallback protocols like Rossen was talking about with, we have it with SockJS today. That's a clear effort to have a transport-focused, multi-language friendly approach to a fallback protocol. And by fallback protocol, again, we mean if we can't do WebSockets, then we fall back to XHR streaming, or we fall back to long polling, or we fall back to JSON-P polling, right, in an agreed-upon order, right, that both the client and the server understand. That's what we mean by a fallback protocol. And there's real value in having consolidation there. This isn't like choices of, you know, client-side web frameworks or something like that. A proliferation here only hurts people. So SockJS is out there, as Rossen mentioned the Engine.io effort out of the Socket.io team. Atmosphere has its own approach with Atmosphere.js in the browser. But as we've already seen, things like Vertex build on top of SockJS. If you go to sockjs.org, which is just a pointer to their GitHub repo, you'll see SockJS in Erlang, SockJS in other languages, and it's quite likely that we'll continue to see that adoption. Which means that frameworks can pick up on that. The different language communities, whether it's Rails or Spring or what have you, can potentially take advantage of that if there's really wide agreement, reasonably wide agreement about that fallback protocol. SockJS, as we kind of alluded to, is perhaps the most promising effort out there, simply because they've been taking the most concerted effort for the most time on separating out this distinct protocol from, you know, they're not being JavaScript-centric per se. And I'd encourage you to go take a look at that protocol effort, again, under their GitHub repo. Full disclaimer here, the lead developer for SockJS works for VMware on the Rabbit team, but we were long impressed by this before some of us even knew that. So questions remain, right? What will the actual usage patterns be? We can see what people have been doing for interesting demos around WebSockets. Lots of things are possible, but how will it actually turn up in the wild, right? And we'll begin to know that as we start to see, you know, articles online and lots of serious use cases and so on. Higher level protocol use, as I mentioned in the beginning, and as you can kind of see as we went through all the protocol details, we don't want to be thinking at these very low levels of WebSocket protocol technology. So what will be the higher level protocols that show up? Will they be kind of bespoke, application-specific micro protocols on top of WebSocket, or will we see something like the advent of XMPP, AMQP, even JMS on top of WebSockets, both in the client and the server? And when you look at vendors, right, like particularly Kazing, they talk a lot about that, and they indeed have a lot of support for that, for higher level protocols on top of WebSocket. So if you're building a real app today, because of that complexity, because of thinking about all the fallback options, commercial vendors really have a lot to offer. And we mentioned Kazing here again, one, because they're probably the most prominent in the Java space, but because they had such an instrumental role in the specification and so on. And they really have excellent resources. We're not affiliated with them in any way, so it's not so much an outright plug, but we got a lot of value during our own R&D from their blog. They're the sponsors of WebSocket.org, which is just a really nice introductory, playing with a simple WebSocket chat application, some facts for the uninitiated, that kind of thing. So definitely worth a look. And what will we see in Java land? Some rough predictions that JSR 356, like Rossen talked about, has been going well. It's been a really reasonable effort that will almost certainly become important. We've seen the individual servlet containers developing their own native support, but this is a great place for a standard, especially since there's an IETF standard out there with the RFC and so on. This is a very reasonable place to have standardization out of the JCP. Frameworks will still have a big role to play here because of, principally, the fallback problem. Right? The fallback protocols, fallback options, that's not really a place for a specification to kick in, at least a JSR style specification, because you're dealing with specific non-standardized technologies, like SockJS and so on. So we'll probably see frameworks having a big role to play. Atmosphere is there today, as Gunnar briefly pointed out, and if you were getting up and running in Java right now with an open source framework, Atmosphere is almost certainly the best bet. This is, of course, where some kind of dedicated support out of the Spring family of projects may make a lot of sense. And again, this is why we did all of this R&D, is to begin to answer that question. We don't have those answers yet, but we're quite interested in your feedback, especially if you've been using WebSockets or think you might be doing so and you're a Spring user. We'd love to hear what you think would be useful. And that's it. I want to talk about Jeremy's session again today at 2:45. He'll be doing some interesting and I think quite fun things with WebSocket. A little bit of a surprise there waiting for you. So definitely check that out. And that's us on Twitter. And again, there's the URL. You can also find the source code there. Thank you very much. And one more comment from Gunnar, and we do have a few minutes for questions for those who want to stick around.
Yes. Also, as you mentioned, this is not necessarily for us just a Spring MVC effort. So we can actually, since this has a more, since we're talking about messaging, etc., so those kind of things can even bleed into Spring integration. So you will see probably even more, some form of SockJS, Atmosphere, etc. support from the Spring integration team. And I know that the Grails team already has, it was mentioned in the keynote, the event bus, which actually uses Atmosphere under the covers. So that's providing also integration into Spring integration. That's available on the Grails side. So I just want to shout out those efforts. So you should see some progress in the coming months, basically, on all those.
Cool. So we have just 5 minutes or so. We can do a few questions, then we can obviously take questions afterward. Anyone? Go ahead. The negatives, I didn't really see anything that would address that. The question is there any downside to using WebSockets internally within an enterprise, within a network where there's no intermediary concerns for something like an internal service-oriented architecture? Yeah, did you have something that you wanted to say?
Just that it relates more to the longer-term concerns rather than the short-term. Go ahead.
I think the main problem is right now, for example, that the support on the Java side in terms of libraries to basically implement, there are basically SockJS or also like Socket.io potential libraries out there. Their maturity to some degree is problematic. I think there's certainly interesting use cases for making using WebSockets for messaging, even like for some internal, particularly for traversing firewalls, etc., to basically not having, if you particularly want to do bidirectional way, you only have to have one port open basically in order to have web services poke holes in both firewalls. So that's certainly an interesting use case. But maturity is probably a big problem right now. So.
Certainly need a protocol on top of it.
And you need protocols on top of the pure WebSockets. I don't really think you want to do pure WebSocket in that regard. To give you an idea that even the Bitcoin exchange, we're using their WebSocket interface, they kind of like deprecated their WebSocket interface in favor of Socket.io for their communication. So just another concern here. But long term, certainly some interesting stuff there.
And I would just mention one other thing is, once again, looking back at Kazing, the company, they basically don't recommend using raw WebSockets. They say it's fine to use, and they even, of course, they provide it as an option. But essentially, they provide multiple implementations of different protocols, client and server side, including in the browser, for JMS, XMPP, and AMQP. So that's probably how it's best to consume it.
Other questions? Yeah.
With traditional like Ajax, there's a lot of restrictions on third-party JavaScript requests back from that and posts.
Third-party JavaScript, sorry.
Third-party JavaScript.
Like cross-domain issues.
Making cross-domain requests, that sort of thing. Is there a similar restriction on WebSockets?
It's actually part of the protocol that cross-domain communication, right? An origin-based security policy actually does allow for this. One of the issues that comes up is you might want to design, almost certainly do in certain cases, you want to design for cross-domain communication in the WebSocket world, but then when you're dealing with the fallback options may not be able to do it, right, if they're XHR-based. So that's a kind of nuanced discussion about how do fallback protocols address that, what can you fall back to, and so on. Open area for discussion, basically. But it is possible with WebSockets by design.
Yeah, so those libraries that provide fallback options, they'll typically deal with that, right? Because otherwise it's not very practically usable. But it's basically, I mean, the point was that it's built into WebSocket protocol, but realistically you'll probably be falling back on options that do require it. Yes?
Yeah, go ahead. So the question, just to repeat it, is do we envision dedicated support in Spring, whether it's in the core Spring framework or like a Spring library that you can download that's like, your words were a Spring atmosphere or something like that that's doing this kind of graceful degradation or fallbacks, right?
I think that the way we envision it to some degree, I think Atmosphere right now is probably the best option, and you see it on the Grails team. They seem to use it. You will see, I'm kind of like behind my schedule, but there should be a Spring Integration Atmosphere adapter out there sometime soon. So we'll have some support on that side. In regards to long-term WebSocket support, that's kind of like, to some degree, open for discussion, and probably Rossen can.
Yeah, and I just want to extend what Gunnar was talking about is that a Spring integration input and output adapter is going to give you sort of a messaging style approach to working with WebSockets. And it's not even raw WebSockets, it's just basically messaging. And because you may fall back, but the idea is you want to stay as close to the actual WebSocket API, so one day we can switch off these fallback options and just start using a messaging style API. Now what we showed you earlier with the Spring MVC integration, that was a Spring MVC controller, and that has little to do with messaging, so it's a very different style API. And it's relatively easy to integrate Atmosphere that way with Spring MVC. But more likely what we would like to provide is sort of a messaging style option where underneath it's using Atmosphere indeed, like under a Spring integration input-output adapter, or perhaps some kind of library which gives you fallback options, and how that's provided is kind of a detail. But it will be some kind of messaging style API.
So we're definitely thinking about it, is the short answer. But it's not yet clear. Yeah. And that's right at 10, actually, so maybe let's break and just take questions below. Thanks again, everybody.